Like earthquakes, volcanoes also belong to catastrophism, which is a part of endogenetic process. Volcanic activity is the sudden and violent process. Normally we think that volcanic activity is associated with eruption of lava, but along with lava, some other materials from the interior of the earth are erupted as a part of volcanic activity. If it is so, what are these materials? What is the periodicity of volcanic eruption? Keeping these views in mind, the main objectives of the lesson are to understand the composition of the volcanic materials, to classify the volcanic activity, to understand the mechanism of volcanic eruption. Volcanism is a broad process through which hot material from the interior of the earth moves to or towards the earth's surface. A volcano is an opening in the crust of the earth connected by a conduit to an underlying magma chamber through which molten lava, volcanic gases, steam or water vapor and pyroclastic material is ejected. Volcanic activity is the result of endogenetic processes or is the outcome of the internal forces of the earth. Volcanism refers to the ejection of the material from the interior of the earth. Generally, when we think of volcano, the mostly think of lava as a part of volcanic eruption. But volcanic material includes other liquid, solid and gaseous materials also. The products of the materials erupted through the volcano are highly variable and largely dependent on the composition, viscosity of lava, gas content, etc. On the basis of silica content, the lavas are divided into two types: acidic lava with higher percentage of silica content and basic lava with low percentage of silica. Lavas are also classified on the basis of mineral content into two types: felsic lava and mafic lava. Felsic lava is the type of lava which is less fluid in nature and is characterized by high viscosity. The felsic lava is rich in iron and silica content. Mafic or basaltic lava is characterized by maximum fluidity. The mafic or basaltic lava spread on the ground surface with maximum flow or spread. Mafic lava has high content of magnesium and iron. Lava flow is divided into two categories: Pa-he-ho and Pa-he-ho, and A type of lava flow. The difference between these two lava flows reflects the flow dynamics. Both these names are Hawaiian volcanological terms. Pa-ho-he lava has high fluidity and spreads on the surface like thin layers of sheet. The Pa-ho-he flow has comparatively smooth or ropey surface. Pa-ho-he lava, when solidifies in the form of sags or pillows, is termed as pillow lava. A lava is more viscous in nature. The surface of the A flow consists of free chunks of angular pieces of lava. A flows when lava flows rapidly. When volcanic eruption is accompanied by a series of explosions, solid materials are ejected. Solid material ejected from the volcanic activity is also called as fragmental or pyroclastic material. The solid volcanic material is also known as tephra. On the basis of the size of pyroclastic materials, they are grouped into 1. The finest particles, which is called as volcanic dust, then volcanic ash, the size of which is 2 millimeter in size, lapilli, the small fragmental or solid materials of the size of a pea, volcanic bobs, that is large size fragments which are of various shapes. The dimension of volcanic bombs is variable, which ranges from the size of a basketball to a giant size. The other solid volcanic materials include scoria, pumice, and cinders. Gases emitted during the course of volcanic eruption includes gaseous compounds of sulfur and hydrogen with carbon dioxide and sulfur dioxide. Besides, certain compounds also ejected with volcanic gases such as sulfurated hydrogen, hydrochloric acid, and volatile chlorides of iron and potassium. Mostly the gaseous material are dissipated directly into the atmosphere. These gases erupts with very high temperature. Steam, vapor constituted 60 to 90% of the total gases emitted during the volcanic eruption. The nature of volcanic activity varies from place to place and from region to region. The variations in the volcanic activity is seen in terms of mode of eruption, period of eruption, and nature of eruption. Thus, volcanoes are classified on the basis of 1. Periodicity or frequency of eruption, 2. Mode of eruption, and 3. Nature of eruption. On the basis of frequency or periodicity of the eruption, they are classified into 3 types. 1. Active volcanoes, 2. Dormant volcanoes, and 3. Extinct volcanoes. Active volcanoes. Active volcanoes are those that have erupted in the recent past. Such volcanoes periodically eject lava, gases, ashes, etc. There are about 500 to 600 active volcanoes in the world. Mount Etna, Mount Vesuvius, Mount Stromboli in Italy, and Mauna Loa or Mauna Kea in Hawaii Islands. Pinatubo in Philippines are some of the examples of active volcanoes. Barren Islands in Andaman Nicobar Islands in India is also an active volcano. Dormant volcanoes. Dormant volcanoes are those that have erupted in the historical periods but have remained inactive for a fairly long time. A dormant volcano, although not active or not been erupted within historic times, however, they may erupt any time in the future. Such volcanoes become quiet after their eruption for some time, and there are no indications of future eruption, but suddenly they erupt very violently. The subsequent eruptions occurred in 1803, 1872, 1906, 1927, 1928 and 1929. Kilimanjaro is also an example of dormant volcano. Some of the volcanoes in West Indies, Philippines and Japan are considered as dormant. Extinct volcanoes. Extinct volcanoes are those volcanoes which have not erupted since remote geological times. They have been inactive for so long that they are not likely to erupt in the future. Volcanoes are considered extinct when there are no indications of the future eruption. Generally, extinct volcano is also called as dead volcano. The volcanic cones of the extinct volcanoes may be highly eroded, and sometimes the cone may have totally disappeared. For example, Arthur's Seat in Edinburgh, Scotland. On the basis of mode of eruption, volcanoes are classified into 2 types: central type and fissure type. Central type of volcanic eruption. In this type of volcanic eruption, the eruption occurs at one point and the magma and other volcanic material rises to the surface through a narrow pipe-like opening called as vent of the volcano. The material thus ejected gets accumulated around the vent of the volcano in the form of a conical hill called as volcanic cone. Usually, central type of volcanic activity is explosive in nature due to the violent explosion of gases. The eruption is so violent that huge quantity of various types of volcanic material like hot gases, lavas, volcanic dust and ash and other fragmental materials is ejected, which may reach up to several thousand meters in the atmosphere. The central type of volcanic eruption is further divided as Hawaiian type, Strombolian type, Volcanian type, Pelian type, Vesuvian type. Now let us discuss about the Hawaiian type of eruption. The Hawaiian type of volcanic activity is not very explosive in nature due to less viscous lava and non-violent nature of gases. The type of eruption is effusive in nature. When basaltic type of lava are of low viscosity, low gas content and high temperature at the vent. In this type of volcanic activity, a large quantity of extremely fluid lava flows out through the central vent to form typical shield volcano. Rounded blisters of hot and glowing mass of lavas, when caught by strong winds, glide into the air like red and glowing hairs. The people of Hawaii Islands consider these long glassy threads of red molten lava as Pele's hair. Pele is a Hawaiian goddess of the fire. Volcanoes of this type have named as Hawaiian types because such eruptions are very common in Hawaii Islands. Strombolian type of eruption. Stromboli is the name of a volcano in Lipari Islands in the Mediterranean Sea. In this type of volcanic eruption, the basic lava is less fluid than that of the Hawaiian type. The lava flows of Strombolian type are more viscous and therefore spread to shorter distance as thick layers. In Strombolian type of eruption, explosions are more common and more fragmental material is ejected along with lava. The fragmental material includes cinders, pumice, lapilli, scoria and volcanic bombs. The ejected material reaches great height into the atmosphere. The ejected material after reaching great height falls down into the volcanic craters. Mount Stromboli volcano in the Mediterranean Sea emits so much of incandescent gases and fire that it has been termed as the lighthouse of the Mediterranean. Volcanian type. This type of volcanic eruption is named after volcano of Lipari Islands in the Mediterranean Sea. Such volcanoes erupt with great force and intensity. The Volcanian type of eruption is explosive in nature due to high content of silica in the magma. The lavas are so viscous that they are quickly solidified and hardened between two eruptions and thus they plug the volcanic vent. The solidification results in a built-up pressure beneath the lava crust in the crater. The plugging of the vent of the volcano obstructs the escape of volcanic gases, lava and other angular fragments. Pelian type of eruption. This type of volcanic eruption is named after Mount Pelee, volcano of Martinique Island in the Caribbean Sea. Pelian type of volcanic eruption is most violent and explosive in nature. The lava eruption is viscous in character. Obstructive lava domes formed above the conduits of volcanoes. With every successive eruption, the lava dome is blown off. Each successive eruption occurs with great force and the intensity. The most disastrous volcanic eruption of Mount Pelee in 1902 destroyed the whole town of St. Pierre, killing 28,000 inhabitants. Krakatau volcano, located in the Sunda Strait between Java and Sumatra, is another example of violent type of eruption of Peelean type. Vesuvian type. This type of volcanic eruption is similar to the Vulcanian and Strombolian type of volcanoes. Difference lies in the intensity of explosion of lavas and gases. There is extremely violent explosion of magma due to the enormous volume of explosive gases. Volcanic materials are thrown up to the greater height into the sky. The ejected enormous volume of gases and ashes forms thick clouds in the form of cauliflower shape. Mount Vesuvius buried Pompeii town in Italy with tephra and pyroclastic materials. Mount Pinatubo in Philippines comes under this category. Fissure type of eruption. In this type of eruption, mostly magma and other volcanic material is ejected through long cracks or openings called as fissures. A large amount of magma is erupted to the surface and spreads over a wider area, forming plateaus. Deccan Plateau in peninsular India is formed due to the fissure type of eruption. Such volcanoes occur along a long fracture, fault and fissures. In this type of eruption, there is a slow upwelling of magma. Fissure eruption is divided into lava flow, mud flow and fumaroles. On the basis of nature of eruption itself, the volcanic activity can also be classified in two types: explosive type and placid or quiet type. Explosive type, some of the volcanoes erupt explosively with great force. Violent explosions are caused due to sudden escape of gases and steam. Sometimes such explosive eruptions blow up part of the volcanic cone. Large amount of rock particles and dust is thrown up to a great height into the atmosphere. The eruption is rapid, violent, that huge quantity of volcanic material consisting of lava and fragmental material are ejected up to thousands of meters into the sky. Such type of volcanoes are very destructive and are disastrous in nature. Mount Krakatoa in Indonesia erupted in a highly explosive manner in 1883, blowing more than half of the island on which it is located. Placid type. In placid type of volcanic eruption, the magma rises to the surface quietly without any explosion. Sometimes it is also called as effusive type of eruption. This happens generally when the magma does not contain large amount of gases. The volcanoes of the Hawaii Islands belongs to this type. Structure and components of volcano. A typical volcano is an opening into the earth's crust through which hot materials from the interior of the earth is ejected and reaches the surface. The narrow opening of the volcano is called as the vent of the volcano. Volcanoes of explosive or central type are associated with the accumulated volcanic material in the form of a cone, which is called as volcanic cone or volcanic mountain. The upper part of the volcano is often a saucer-shaped depression called as the crater or mouth of the volcano. The volcanic eruptions are associated with the weaker zones of the earth's surface, represented by mountain building, plate margins and fracture zones. The mechanism of volcanism is closely associated with several interconnected processes such as gradual increase of temperature with the increasing depth at the rate of 1 degree centigrade per 12 meters due to the heat generated from the disintegration of radioactive material deep within the earth. Origin of the magma because of the lowering of the melting point caused by the reduction in the pressure of overlying superincumbent load due to the fractures caused by splitting of the plates and their movement in opposite direction. Origin of the gases and water vapor due to the heating of the water which reaches underground through the percolation of rainwater, water formed due to the melting of the ice and snow. The ascent of magma forced by enormous volume of gases and vapor. The occurrence of volcanic eruption of either violent central explosive type or quiet fissure type depending upon the intensity of gases and vapor and the nature of crustal surface. It has established by the geologists that there is a close relationship between the movement of the plates of the earth and the volcanic eruption. In the recent times, theory of plate tectonics provided a very scientific explanation of the process of volcanism. Plate tectonics very well explains the mechanism of volcanism and volcanic eruption. In fact, volcanic eruptions are closely related with the plate boundaries. The type of plate movements and the plate boundaries also determine the nature and intensity of volcanic eruption. The splitting and the divergence of the plate creates fractures and faults which cause pressure release, lowering of melting point, and thus materials of the upper mantle lying below the mid-oceanic ridges are melted and move upward as magmas under the impact of enormous volume of accumulated gases and vapor. The divergent or the constructive plate boundaries are associated with quiet type of fissure flows of lava because the pressure release of superincumbent load due to the divergence of the plates and formation of fissures and faults, which is a very slow and gradual process. Explosive type of volcanic eruption is associated with convergent or destructive plate boundaries. When two converging plates collide along with the Benioff or subduction zone, relatively denser plate is subducted beneath the comparatively lighter plate. The denser plate, which is subducted after reaching a depth of 100 km or more in the asthenosphere or upper mantle, is melted. Thus, magma is formed. This magma is forced ascent by the enormous volume of accumulated explosive gases, and thus magma appears as violent volcanic eruptions on the Earth's surface. Such type of volcanic eruption is very common along the convergent or destructive plate boundaries, which represents the volcanoes of Circum-Pacific Belt. Volcanic activity associated with the island arcs and festoons of the coast of Asia are caused due to the subduction of oceanic plate like Pacific plate below the continental Asiatic plate. It is thus seen that volcanic activity belongs to the endogenetic process. The frequency or the periodicity of the volcanic eruption is not uniform. Sometimes the volcanic activity is explosive, at times very silent and quiet. Besides lava, the volcanic material can also be in the form of gases and solid fragmental materials. Plate tectonics gives a very plausible explanation of the volcanic activity. Fissure type of volcanic eruption is associated with mid-oceanic ridges or divergent plate boundaries, whereas explosive type of volcanic activity is common along the convergent plate boundaries.